What is AgriPod? Well, it's not just the sensor that we've made. We've designed an entire system to protect farmers from fertilizer misapplication. It's a really big problem in especially developing countries, where you can apply fertilizer at roughly the right times, sort of months and weeks. But if you don't get it specifically on the right conditions, you can lose a lot of the fertilizer. So for example, if it's just rained and it's too wet, the fertilizer can run off on the soil and go into the water supplies and contaminate drinking sources. So essentially, what we've done is create a sensor which transmits data back to us, where we can then process that, and then we send the farmer a recommendation via SMS to then tell them about which days or hours even to apply the fertilizer. And hopefully with that, we want to increase the fertilizer efficiency and reduce the cost for the farmer.
So the AgriPod is really just a system to maximize the efficiency of fertilizer. So that's sort of an abstract concept, but it basically means that when a farmer goes to apply fertilizer, the AgriPod will tell them when to do that so that he maximizes the amount of fertilizer that's taken up by the plant and maximizes the growth from the fertilizer rather than wasting it and it then going into streams in the air and things. This device basically records data and sends it straight off to my computer basically, which stores the data and then uses it so it can learn patterns about temperature, soil moisture and fertilizer and that sort of thing.
So the idea for AgriPod, well, it sort of started when I watched a YouTube video just about some sort of farming technology sort of thing. I think some guy made something in his own back garden. And then a couple of days later, I got an advertisement for sort of a farming system. And out of curiosity, I had a look and I was kind of like shocked because it was super simple. It was literally just a sort of a thing that a farmer can will put in their field and it measures temperature or something. Just literally gives them the raw data, nothing else. And that thing costs a couple of £1,000s. And I was really just thinking like, I can make that. So we took a look into it. We looked at some sort of other solutions around and we found that in the West, a lot of these systems are really, really expensive and they use existing infrastructure. So when you try to apply that to a poorer country, a poor area like northern India, it ends up that the farmers, even if they could afford these machines that cost thousands of pounds, they don't even have the local infrastructure to support that. So we then started to look at some problems that we could solve just using low-cost solutions which already use the existing infrastructure. Like we're using the local 2G network in India for our pod. And eventually, after doing some research and talking to some experts, we landed on the problem of fertilizer misapplication.
I have family who run farms in India, and I visited these farms about 2 years ago, and I talked to a few of the farmers, and I really discovered that one of the big issues that they're faced is that there isn't really enough technology right now in developing countries, especially in the agriculture sector. And what I did is I talked to Lucas and Ali, and we decided that an agricultural technology system like the one we've made has the potential to better people's lives, and we embarked on AgriPod.
Well, so from my perspective, what I did to make the prototype was simply, program the server so that it can receive the data from that device, what that sensor's measuring, and really, just store that data and then eventually use that to program a machine learning algorithm. The physical construction itself was done, almost exclusively by Lucas, where he's, if you open it up, you'll see inside there's lots of wires and things, and of course you can see the 3D printed construction. That was all Lucas's work.
First of all, we spent quite a lot of time, because we don't really have that much money to spend on this thing. So we spent a lot of time doing it digitally. So we sort of made 3D models, rendered it, and sort of perfected the design in the computer without making it first. And then once we got to the stage where we felt comfortable actually making it, I hopped onto my 3D printer, put in this design and printed these separate parts to make them all fit together. Then I chose some electronics for it. So we're using pre-made components. We chucked them all in, programmed it to make it work with Ali's code, which took a long time. So essentially you can stick this into soil some sort of bit of soil anywhere, and it will start transmitting over Wi-Fi.
So my role wasn't really centered around the actual prototype. It was more looking at how we would actually implement our device in India. So looking at a business case for AgriPod. So I looked at different ways we can distribute our device. So we contacted loads of different NGOs in India, and we've got a lot of positive responses from them regarding that. And I also talked to end users, such as Omkar Singh. He's a farmer in Uttar Pradesh, and he really liked the idea. And we hope to eventually trial AgriPod with him in India.
So really our future plans are firstly to test the device in England and make sure that the basic functionality works. And depending on the success of that test, it's hopefully in June of next year, we'll send this device off along with a few others to Omkar Singh because June is the fertilization season in India. And he will basically test the device on a field and compare the fertilizer used in that field to a field without this device, without the system in place. And basically, we're just going to make sure that the system actually works. After that, we're going to really ramp up distribution. We're going to try and distribute to a few more farmers so that we can actually get to the point where we're testing it on a much larger scale. And after that point, I think it's hard to say what will happen. But I know that, for example, the cost of the unit costs for these devices will decrease at scale. Also, as we collect much more data, we'll be able to come up with new patterns that we hadn't before been able to spot.
So I think really one of the most exciting parts of AgriPod was actually talking to people such as the Indian Minister of Agriculture in Tripura, which is an Indian-based agricultural state. So it was really amazing that we just contacted him, and out of the blue, he was happy to call us up. But because obviously of time changes, he had to call me at 5 a.m. in the morning. So I woke up at 4 that morning, and then he called me up at 5. And we spoke about AgriPod, and he was really interested in the idea. And I think he eventually wants to try and trial it in India.
It's a really big honor to be a finalist in the Big Bang because there was a few times some part of the competition was held actually here in Leicester Grammar School, and so I'd always walk past and think, yeah, that's really cool. I really want to take part in that. And I think also it's an honor because this isn't the sort of competition where you just fill out a form or answer some questions and bosh, that's it, you're a finalist. This is the sort of thing where you really have to put in a lot of work. We've put in hours and hours of work into creating our own device, creating our own prototype and a plan, and to see that someone else has recognized the value of that means a lot.
The reaction to us getting into the finals was quite shocking. I think it came completely out of the blue. I don't even think my family knew that I entered it because I've been tinkering around at home a lot with just various projects, making stuff. And this is the first competition we entered, and then also being recognized for that was seriously cool. I definitely think my parents didn't really understand what it was at first. So yeah, showing them the website, sort of telling them what it was, and really saying that we need to go somewhere and present this thing in front of thousands of people. And then at that point, I think they started to really appreciate what it was.
Entering the Big Bang competition was really a great opportunity because it gave me the chance to put ideas and theories that I'd learned inside the classroom actually into practice when we were building the device and when I was designing the plan for distribution. And I think that is something I will remember.
My STEM inspiration, I'd say, is probably some mix between maybe Elon Musk and Steve Jobs. I really like Elon Musk because obviously he's renowned for his work ethic, and also because he takes on so many different projects at the same time. He's doing several impossible things at once. He's making reusable rockets at the same time as he sort of led the team that designed the first really equivalent electric car to the gas-based alternatives. And at the same time, I really appreciate Steve Jobs' genius in just understanding the market, understanding what people wanted without them even saying it. With his products, they were so ahead of the time. market research didn't say people wanted an iPhone. Steve Jobs knew people wanted an iPhone, and I really aspire to that.
So the light bulb moment for getting into engineering for me, I would say it was a couple of light bulb moments. You can sort of say little bulbs. The first one was when my dad sort of told me one Christmas that you can build your own PC. I'll get you the parts and we can build it together. And from there, I sort of looked at these really cool components, expensive components, and sort of saw, well, these are seriously cool. If you put these random things together, you get a computer that works and can run, infinite amount of things. And then from then, I became more and more interested in electronics. And then at one point, I got myself an Arduino. I think this is what I would say any aspiring engineer should do. Tinkering with an Arduino is one of the best things you could ever learn. It teaches you electronics, it teaches you programming, it teaches you to think like an engineer. And just, it gave me so much inspiration to do lots of different projects. I mean, like, I tried doing an automatic blind closer, sort of like an automatic door closer, because my parents would never close my door in my room when they left. Just sort of stupid stuff like that is one of the best ways to get into engineering, in my opinion. What are my future career aspirations? Well, I think primarily I want to go into sort of consumer electronics. What really, really fascinates me is really, really small things, so semiconductors. I think what was really a starry-eyed moment for me was when Apple unveiled their own silicon, and sort of looking at them and being like, that team in that lab there in California, that is where I want to work. So sort of anything to do with chipset design, perhaps systems architecture. I know the route is long. I think it's like a minimum you need a PhD to get in that field or something like that. But sort of in that direction is really where I want to go. Although recently I have been looking more at general electronic engineering. I've been really lucky to be sponsored by the company Leonardo, which do defense systems, and it's been really, really cool seeing what they do.
So in the future, similar to Ali, I really want to kind of go into economics, and I think that's really where I want to spend my time doing for the next few years, perhaps pursue a PhD at university. I don't really know where I want to go after that, but I guess I'll see what the future holds.
As for my sort of career aspirations, it's a really hard question to answer, to be honest. But I think I want to go into something with either finance or technology, or really both, ideally. Because, on the one hand, I have a sort of running obsession with finance. I regularly read books about finance. And when I hear about, for example, the Goldman Sachs trading desk, when they managed to single-handedly sort of save Goldman Sachs from major losses in 2008 and 2009 by spotting something which, the majority of other bankers just didn't spot. I want to be on that team. And when I look at technology, I want to be, the guy who invents things, the person who's known for inventing things. That's a big aspiration for me. And I think I would be most happy with something that would combine both of those aspects, the predictions of finance with the sort of innovation and creativity of technology.
Yes, we're hugely proud that the boys have made it through to the Big Bang finals. They worked really hard on this project, and I think they've managed to hit a really sweet spot. They've got a product which will bring immediate economic benefit to farmers in northern India. So there's a real motivation there for farmers to use it. But at the same time, there's an environmental benefit. Actually, if this product can reduce fertilizer application, reduce fertilizer runoff into streams and rivers, there's an environmental benefit. So they've done a great job on the product itself. I think over and above that, they've gone from what is a really good idea, and actually they've moved quite a long way down the road towards actually a product that could work in real life. They've done some great work around the electronics, around the physical build of the product, actually produced a prototype that can take measurements. They've done some fantastic work around coding, and they've actually built an algorithm that will take specific data points and translate that to a whole field's worth of readings. And then actually Addy's worked really hard on the business case for this. They've got NGOs who they think could distribute this in northern India. They've thought about a leasing model so that farmers don't have to pay up front. So I think overall, yeah, we're really proud of them. They've worked really hard on it, and they've taken a great idea and moved that quite a long way down the road. We think the teaching of STEM and STEM subjects is an absolutely core part of the curriculum at Leicester Grammar. Clearly, pupils need to study the technical subjects in their own right, their science, technology, and maths, and they need the theoretical knowledge that comes from those subjects. But the challenge, and what these pupils have managed to do with this project, is move from purely theoretical ideas through to a concept and actually a product that has a real life application. And they've seen a real need, which Adi has seen whilst visiting relatives in northern India, and they've looked at that need through the lens of their technical know-how, and they've come up with a product, an idea and a product that actually could serve a real purpose in the community. And it's something that I believe would benefit farmers in northern India and has a really positive environmental impact as well. And that's what we're aiming at Leicester Grammar, to see those technical ideas taken from the classroom out and begin to be applied in the real world.